So unit circle, very, very, very important, not just in this class, but in every math class, really, not every math class, but calculus-based class that you'll take after this. So as far as this class is concerned, in other classes, actually I've seen a variety of things. Sometimes the unit circle has to be memorized, sometimes it doesn't. In this class, obviously there's no way for me to monitor whether or not you're looking at the unit circle, so I will not make you memorize the unit circle. What we're going to do today is we're going to create the unit circle. So you're going to see, where do these numbers come from? How can I use sine, cosine, and tangent with the unit circle? What's the point? Where are my radians? What's the difference between radians and degrees? We're gonna make that. We're gonna put that all together today. And at the very end, you'll see the very last slide is a picture of what we call the unit circle, and that's going to kind of be the compiled from everything we do today. So even though you don't have to memorize it, it's still really good to know where these things come from, so that in the future, in a college level class, you'll definitely have to have the unit circle memorized. So at least you'll have a little bit of background on it. Okay, so let's jump on in. So a unit circle simply means it's a circle with a radius of 1. And that's what they have pictured here. Notice my radius is 1. So from the center to along each axis, you can see that it's a length of 1. It would then obviously be a length of 1 anywhere else I drew in a radius. That is the unit circle. That is the key point here, is that it has a radius of 1. So everything we do today, at least until the very, very end, is going to build off of this unit circle. Now, we're going to touch back on that trig. You probably first started hearing about trig in geometry when you use SOHCAHTOA, right angle trig. Today we're going to look at trig a little bit differently. So we have the 3 trig functions, sine, cosine, and tangent. And we abbreviate that to SIN, COS, and TAN. Don't ever call these sin, cos, and tan. Just makes you sound, I don't know, silly, I think. So it's always sine, cosine, and tangent, even though we write SIN, COS, and TAN. Sine, cosine, and tangent. And in the unit circle, now, only when we're talking about the unit circle, so a radius of 1, we have these 3 things to be true about sine, cosine, and tangent. Sine of our angle is simply equal to the y-coordinate of my position. Cosine of our angle is equal to the x-coordinate of our position, and tangent of our angle is equal to the y-coordinate divided by the x-coordinate. Now this is huge. We use this throughout the entire lesson. So sine is equal to y, cosine is equal to x, tangent is y over x. Now, how can you remember that? I always think of it alphabetically. Cosine comes before sine in the alphabet, C before S, X before Y. So cosine is the first, sine is the second, X goes with cosine, sine goes with Y. Sine goes with Y. Now, have you ever seen these 3 terms before? Cosecant, secant, and cotangent. Can you give me a yes or no in the questions box? Have you ever seen these 3 trig functions before? Only on the pretest? No. Okay, so in geometry, when you worked with trig, sine, cosine, and tangent, you learned those 3 functions. There's actually 3 more functions, cosecant, secant, and cotangent, and they're simply the reciprocals of sine, cosine, and tangent. So cosecant is simply the reciprocal of sine. Secant is the reciprocal, that's a hard word to spell, of cosine, and cotangent is the reciprocal of tangent. Okay, remember reciprocal just means flip the fraction. So you can see here, since sine was equal to y, cosecant of t is equal to 1 over y. Secant of t is equal to 1 over x, since cosine was equal to x. And since tangent was equal to y over x, cotangent is equal to x over y. So these 3 functions, and we'll look at them, how we can find them in our calculator as well later on in the lesson. But these 3 functions are just reciprocals of our previous 3 functions. Okay? And we'll just work with them enough to hopefully where you kind of get an understanding of that. So we're going to start by, what we're doing here is we're building a unit circle. Little by little, we're adding on, and you'll kind of see it kind of all come together at the end. So it says, Find the values of sine of t, cosine of t, tangent of t, cosecant of t, secant of t, and cotangent of t. So in other words, anytime they say all 6 trig functions, this is what we're looking for. If we have the point -1/2 and square root of 3 over 2, which is a point on the unit circle, which corresponds to the real number t. So our angle here is t, and that corresponds to this point, -1/2 square root of 3 over 2. So just simply think of that as x and y. So really, all we're doing is we're identifying our y's with our sines. So we would say sine of t is equal to my y value for my point. So sine of t is equal to the square root of 3 over 2. That's it. Cosine of t we associate with our x value. My x value is -1/2. Not too bad there, right? Picking out the y coordinate, putting a sine, picking out the x coordinate, putting with cotangent, or excuse me, cosine. Tangent of t, and remember we said tangent is equal to y over x. So y is the square root of 3 over 2 over x, which is -1/2. Well, when I'm dividing fractions, it's the same thing as multiplying by the reciprocal, which would be square root of 3 over 2 times -2 over 1, or copy, dot, flip. Well, you guys taught me that. And then when we multiply across, -2, times the square root of 3 over 2, and a 2 on top and a 2 on bottom cancels. So really I'm just left with -3. So tangent of t is equal to -square root of 3. Keep going, we want to find the other 3 functions. So cosecant of t, that's CSC, cosecant of t is equal to the reciprocal of sine of t. So these are just reciprocals. So my cosecant of t would be 2 over the square root of 3. Questions on that much? Any questions? Now, here's our rule of thumb. Hopefully this is something you've heard before. Rationalizing the denominator, or simplifying with radicals. We can't have a square root in our denominator. It's against our rules of mathematics. We never want to have square root in the denominator. So we need to rationalize this. To get rid of a square root in the denominator, you multiply the numerator and the denominator by whatever your square root is in the denominator. So now my new numerator is 2 times the square root of 3, and my denominator, a square root of 3 times the square root of 3 is simply 3. And simplify if you can. In this case, that is my simplified answer. So cosecant of t is 2 square root of 3 over 3. Have you seen that process before? Never. Yes, I think so. Yes, okay. So if you haven't seen it, it's really not too hard to catch on to. If you need some extra help, just holler. I mean, I can teach you that whole process. We can practice it in 10 minutes or less. But right now I want to keep moving on. So anytime, though, we end up with a square root in our denominator, we have to rationalize it. Okay, moving on. We need secant of t. Secant is our reciprocal of cosine, so -2 over 1, which we would just say is -2. That one was much nicer. I'm going to come down here. Cotangent of t is just the reciprocal of my tangent. So tangent of t was square root of 3, so the reciprocal, or negative square root of 3, the reciprocal is -1 over the square root of 3. And now we have that same issue. I have a square root in the denominator. I need to rationalize my denominator. Multiply the top and the bottom by the square root of 3 and simplify. -1 times the square root of 3 is negative square root of 3. Square root of 3 times square root of 3 is 3. So my cotangent of t is square root of 3 over 3. Questions on any of that? How can I move the negative? So when we're working with a fraction, it actually doesn't matter at all where my negative is. If it's on top, if it's on bottom, or if it's in front. Typically, we see it either on top or out front rather than in the denominator, but it does not matter. There is no, it's just kind of a habit, is I always like to put it on top. You might see it like off to the side, just like that. That's kind of still on top. Off to the side would be more like that. Doesn't matter. Either way means the same thing. Okay, good question. So how do we feel about this? Give me a 1 to 5 rating, how comfortable you feel with that whole process we just did. Because that's what we're going to be doing a lot. Okay, cool. Got 2 people answer. Okay. Everything's between a 3 and a 5 so far. So that's really good. And we're just going to kind of be adding steps to it as we go. Okay, so when we're looking here, we're just kind of looking at some pictures of our unit circle. Sorry about that. Looking at some pictures of our unit circle, and really they're just showing you how we can talk about it, how we can talk about our unit circle. So here my arc length is t, and that corresponds to an angle. Remember we introduced theta. That's our Greek letter theta last week. When we talk about theta, we're typically talking about our angle in radians, and t here is just the length of my arc, and we'll kind of look at that a little bit closer. So if theta is equal to t radians, so again, in our unit circle, just like we talked about sine of t, cosine of t in the last example, we can also use our theta, our angle, in there as well. And this isn't a super important slide. That will kind of just come with practice. We'll kind of see that all pulled together. So here's where the bulk of building our circle comes from. We're going to start by building along our axes. Okay, and that's what this AB and then coming up CD is all about. We're building along our axes. So it says find the exact value of each of the 6 trig functions. So we're just going to do A. A is the only thing that's going to fit on this slide. We'll do B on the next slide. And I want to find theta of 0, or at 0 degrees. Now remember last time we talked about our circle. An angle at 0 degrees would have its initial side, make that on, and its terminal side along the positive x-axis. So that would be this point right here. Okay, 0 degrees would be along the positive x-axis. On the unit circle, this would be the point, my radius of 1, I've come over 1 and up 0. I'm looking at the point 1, 0. This corresponds to theta equals 0 or 0 degrees. Okay, so now that I have that, finding my 6 trig functions is just identifying my y and x. So sine of theta, actually we're going to say sine of 0 because we know what my theta is. My theta is 0. So sine at 0 is my y, which is 0. Cosine at 0 is my x, which is 1. Tangent at 0 is y over x, so 0 divided by 1, which is 0. Cosecant of 0 is the reciprocal of 0. So it would be like trying now to divide by 0 or 1 over 0. So that is actually undefined. We cannot divide by 0, so cosecant of 0 is undefined. Secant of 0 is my reciprocal of 1. 1 over 1 is 1. And cotangent of 0, I'm going to have the same issue I had with cosecant. 1 over 0, which cannot happen, so it is undefined. Questions on that much? Okay, let's look at B on this slide. Now, yesterday we talked about converting radians to degrees. So pi over 2 radians is the same thing as 90 degrees. We're not going to actually look at those conversions today. We looked at that last week. But just kind of take it on faith. We're looking at 90 degrees. Now remember, we talked about our initial side on a positive x-axis. 90 degrees is counterclockwise. So 90 degrees would be coming up here to this point along the positive y-axis. Unit circle, so all of my distances are 1. So this point would be the point 0, 1. And again, that corresponds to theta equals pi over 2, or 90 degrees. Okay, again, same process. Find our 6 trig functions. Sine of pi over 2, remember this is radians. Anytime we don't have a marking, it's in radians. Sine of pi over 2 is 1. Cosine of pi over 2 is my x, that's 0. Tangent of pi over 2 is 1 over 0. So in this case, it's undefined. I can't divide by 0. I'm going to come over here. Cosecant of pi over 2 is my reciprocal of sine, so 1 over 1, which is 1. Secant of pi over 2 is my reciprocal of 0. I can't divide by 0, so in this case, secant is undefined. And cotangent So remember here, tangent was y over x, which means cotangent is x over y. So it would be 0 over 1. I can divide by 0. In this case, I get 0. Okay, so question on how I got the 0 and 1. So I'm working along the unit circle. So that means that every distance I go from my origin is going to be a distance of 1. From my origin, anywhere I go is a distance of 1. I'm building what we call the unit circle, which we kind of saw here. Remember, my radius everywhere is 1 unit. So I'm building what happens at 90 degrees, okay? To find 90 degrees, I make my angle. The initial side is along the positive x-axis, and a positive degree says to go counterclockwise. So I've gone counterclockwise 90 degrees. So this angle right here is a 90-degree angle, or right angle, and I've gone up a distance of 1 for my terminal side because my radius is 1, because I'm working on the unit circle. So this is now the point. Just like think about if you were in a coordinate plane. I've gone left and right 0, so my x is 0. I've gone up 1, so y is positive 1. Very good question. Okay, we're going to keep working our way around the circle. Part C says find when we have pi radians or 180 degrees. So I'm starting the same exact way. Initial side along the positive x-axis. Terminal side coming counterclockwise 180 degrees makes this a straight angle. So this is my point. Again, I'm going every distance is a distance of 1. This time I've gone left, so it's negative 1, and I've gone up and down 0. So negative 1, 0. Questions on that much? And then we're going to do the same exact thing. We're going to see a lot of kind of repetition here. So sine of theta, and we'll kind of run through the, or excuse me, sine of pi, in this case my theta is pi, is negative 1. Cosine of pi is 0. Tangent of pi is 0. Oh, I have these backwards. Sorry. Ignore me. Sine of theta is your y. That's 0. Cosine is negative 1. Tangent of pi is 0 over negative 1, which is 0. Cosecant of pi, we would divide by 0, so that's undefined. Secant of pi would be negative 1 over 1, so negative 1. And cotangent of pi, again, trying to divide by 0, undefined. Austin, just pick up wherever you left off, so we're on slide 12, and then watch the rest on the recording. Isn't tangent undefined? No, because remember tangent is y over x, so 0 over negative 1. We can have a 0 on the top, we just can't have 0 in the denominator. Does that make sense? Yep, no problem. Cotangent is x over y. Tangent is y over x. So there's kind of a lot of new rules, so just always refer back to these two slides whenever you have those questions. But very good question. Thank you for bringing that up. Okay, we've got one more like this, and then we're going to move on to something a little bit more intense. So again, start with your x and y plane. Your initial side is on your positive x, and I need to go 270 degrees. Positive means counterclockwise, so here's 90, here's 180. 270 degrees is straight down my negative y-axis. Oops. And I come down a unit of 1, so I've gone left and right 0, down 1. So I get 0, negative 1. On your notes, I want you to fill in all 6 trig functions. I'm going to do it on the computer without saying it out loud, so you can check your work with me as you go. Just look up at my screen. See if you're figuring out your sine, cosine, tangent, cosecant, secant, and cotangent. You don't have to type it, just do it in your notes and then check it with mine. And then ask if you have any questions. Okay, great, Austin. Thanks for coming back. Austin, I'm having them answer these on their own and then just on your notes and then just check it with mine as you go. That's why I'm not saying the answers out loud. You don't have to type it to me. This would be a lot to type. So just do it on your own. Check it with mine. Ask if you have any questions, and then let me know when you're good to go. Just type that you're good or you got it, whatever the case. Okay? Yes, so cosecant, that's what CSC stands for, is just the reciprocal of your sine. So if sine is -1, the reciprocal would be 1 over -1, which reduces to -1. So these two, put in my color, sine and cosecant are reciprocals. Cosecant and secant are, cosine and secant are reciprocal, and tangent and cotangent are reciprocals. So just 1 over what you previously had. Why are some of them undefined? Because, so when I take the reciprocal of 0, I would get 1 over 0. That's my reciprocal of 0. I can't divide by 0, so it is undefined. That's okay. I understand it's going to be confusing. And kind of also keep in mind right now, we're building something that at the end, I'm going to give you a picture of that you can use. So you don't necessarily have to know exactly where everything comes from or be able to come up with it on your own. It's really just coming down to getting familiar with your sine, your cosine, and your tangent, and then finding those reciprocals, knowing sine goes with your y, cosine with your x. We're going to keep going with this process, so if you don't get it all right now, we're going to kind of keep doing this same process the whole rest of the lesson, and then, like I said, come up with our culminating unit circle. So it doesn't make sense right now. Stick with me, kind of keep powering through, and hopefully we'll get you to a point where we're kind of understanding it better. Okay? Austin, yes, and we'll talk about that at the very end. Okay? But right now, rather than it being important how to do it in your calculator, right now what's important is knowing that sine and y go together, cosine and x, and tangent is y over x. So right here is just a chart, and we have this at the end of each of these little sections, summarizing exactly what we just found. So rather than having to go back through your notes and look at each individual slide to find them, you can find it right here. At 0 radians is the same thing as 0 degrees, and here is all of your 6 trig functions. Pi over 2, pi, 3 pi over 2. So again, we're going to keep talking about where these come from, but I'm also giving you the answers as we go as well. Okay? So find the exact value of sine of 3 pi. So let's think about where 3 pi would be for a minute. Remember we said in radians, this is radians because there's no degree marking. In radians, 1 revolution, so all the way around, is 2 pi. So all the way around is 2 pi. That means halfway around is pi. So if I've come all the way around and then round again halfway around, I've gone 3 pi radians. So in this case, on my unit circle, this 3 pi will be the exact same thing as pi was, right here. So 3 pi and pi would correspond to the exact same point, and that's the point -1, 0. And so to find sine of 3 pi would be like sine of pi, which is 0. Okay, let's look at another one like that. Cosine of -270 degrees. Now remember, we said negative means go clockwise 270 degrees. 1/4 turn is 90, halfway around is 180, a third of the way up, there's my 270 degrees, -270 degrees. So this corresponds to the point 1, 0, which is like the exact same thing as cosine of +90 degrees. So cosine of -270 corresponds to my, oh, and you know what, I wrote that wrong. I'm sorry, this should be 0, 1. 0, 1. So cosine of 270 is my x-coordinate, which is 0. Okay? We're just going to keep kind of throwing some more things your way, still kind of doing these same processes. Okay, now we're going to look at pi over 4, which corresponds to 45 degrees. Again, we're building this unit circle. If you can't repeat this all on your own, that's okay. It's just nice to know where it comes from for when you will have to have it memorized. Just kind of bear with me here what we're going to do. So, pi over 4, an angle of pi over 4 radians is the same thing as an angle of 45 degrees. So it's exactly halfway between my x and my y axes. And it actually corresponds to the line y equals x, right? 45 degrees would be halfway. That's that perfect, perfect line, y equals x. So what we want to look at here is creating a right triangle that corresponds. The hypotenuse is my radius, and then my sides are here in green. Since my radius is of the unit circle, my hypotenuse has a length of 1. This length from my origin to the horizontal is whatever my x-coordinate is, and from my x-coordinate up to my hypotenuse is my y-coordinate. So that then this point would be the point xy. So this is a right triangle. Let's think about what we know about right triangles. I can use the Pythagorean theorem to find x and y. I could say x squared plus y squared equals 1 squared. Because it's a right triangle, x and y are my legs, 1 is my hypotenuse. Now, notice this is a 45-degree angle, which means this angle up here is a 45-degree angle, which means this is an isosceles triangle. So, since base angles are the same, x has to be the same as y. Whatever my x-coordinate is, it's the same as my y. Whatever this length is, it's the same as this length. So I'm going to substitute in x for y into my Pythagorean theorem, and I get x squared plus x squared equals 1 squared. So all I did was substitute x in for y. And let's solve one variable, one equation. X squared plus x squared is 2x squared. 1 squared is 1. Divide both sides by 2. X squared is 1/2. And to get x by itself, we're going to take the square root of both sides. So x is equal to the square root of 1 over the square root of 2. Square root of 1 is 1 over the square root of 2. Now here's our I can't have a square root in the denominator, so I need to rationalize it. Multiply the top and bottom by the square root of 2. So on top, 1 times the square root of 2 is the square root of 2, and on bottom, square root of 2 times the square root of 2 is 2. Okay, so I have a question. How do we know that x is equal to y? Because this triangle, I'm just going to draw a bigger version. We had 1 here, x, y. It's a right triangle, and this angle was 45 degrees, right? Because that's how we created our triangle. We created along that 45-degree angle. Well, now we know, so in a triangle, my angles have to add up to 180, correct? So if this is 45 degrees, this has to be 45 degrees in order to get all my angles to equal 180. Now, remember your geometry. These would be what we call base angles. If base angles are congruent, that means I have to have an isosceles triangle. Isosceles triangle means I have two sides congruent, which would mean my two legs have to be equal. You may have learned like shortcuts for what we call a 45, 45, 90 triangle. This is that example. 45, 45, 90 means my legs are congruent, and then I have my hypotenuse. Very good question. So, solving for x, we said, okay, x is equal to the square root of 2 over 2, which means y must also be equal to the square root of 2 over 2. So my point, when my angle is at 45 degrees, or at pi over 4 radians, my point is the point square root of 2 over 2, square root of 2 over 2. That's my answer. That's what I'm looking for in this case. How about now, though, Hannah? Does that make sense? Things kind of clicking? Okay, cool. And again, I'm not expecting you to recreate all of this. I'm just trying to give you a little bit of a reason behind where this comes from. I was not taught the unit circle this way. I was just literally given it, and it was just a mystery to me until well into college. So I think it's more beneficial, and when I've taught this before, I've taught it this way. And again, you don't have to create it yourself. You don't have to necessarily get every step, but I'm giving you a reason behind what we're doing just to hopefully make it make a little bit more sense, and it's not just a big mystery for the rest of our lives. Okay? So now, this is just a picture of what we just did. Exactly, Rachel. Good. And we want to find the 6 trig functions, just like we did in the slides up there. So we're going to start with, I always like to start with sine. You don't have to. There's no rule. So sine of pi over 4 remember we said sine corresponds to our y, which is square root of 2 over 2. Cosine of pi over 4 is our x, also square root of 2 over 2. Tangent of pi over 4 is y over x. So square root of 2 over 2 over square root of 2 over 2. Multiply, copy dot flip, or multiply by the reciprocal. So square root of 2 over 2 times 2 over the square root of 2. 2 root 2 over 2 root 2, that's just 1. So tangent at pi over 4 is simply 1. And maybe you could see that up here too. You're dividing the same value by itself. Keep going on. We've got our cosecant of pi over 4. We said that was the reciprocal of sine. So flip sine, I get 2 over the square root of 2. But again, I can't have that. Can't have a square root in the denominator. So multiply both sides by, or excuse me, both top and bottom by the square root of 2. On top, I get 2 times the square root of 2. All over, square root of 2 times the square root of 2 is 2. And a 2 on top and a 2 on bottom cancel. So cosecant at pi over 4 is square root of 2. Secant at pi over 4 is going to be this exact same process that we just did here. We're going to take 2 over the square root of 2, and when we rationalize that denominator, we get simply square root of 2 because they're the exact same values. And lastly, cotangent at pi over 4, the reciprocal of 1 is just 1. Questions on that much? Hopefully now maybe we're getting a little bit more comfortable with our x's and our y's and our values. And like I said, we're just going to kind of keep practicing. Okay? Find the exact value of the trig function, or the trig expression. So here, we're just going to plug in the values we know. So sine of 45 degrees times tangent of 45 degrees. Well, let's go back to this previous slide. What was sine at 45, which would be the same thing as sine of pi over 4, square root of 2 over 2. So I can replace sine of 45 with square root of 2 over 2 times tangent at 45. Tangent at 45 degrees, which is the same thing as tangent at pi over 4, is 1. So sine of 45 times tangent of 45 is the square root of 2 over 2 times 1, which is just the square root of 2 over 2. Go ahead and try B on your own. I'm going to do the same thing. I'm just going to fill it in without talking. And let me know how you do. Figure out what secant of pi over 4 is, multiply it by cotangent of pi over 4, and see if you can come up with the right answer. And let me know when you're good to go, or if you have any questions. Okay, 2 of you are good. I'm going to wait to hear from all 5 of you. Okay, so I have a question here. Secant of pi over 4. Let's start there. Secant of pi over 4 was square root of 2. So secant of pi over 4 is equal to the square root of 2. They are the same value. 2 different ways of talking about the same thing. Secant of pi over 4 is square root of 2. So I've just simply replaced, oops, I can't do that, this first term with square root of 2. Cotangent of pi over 4, going back here, we said cotangent of pi over 4 was equal to 1. So cotangent pi over 4, replace that with 1. Square root of 2 times 1, square root of 2. Yep. So, and we'll, at the end of after the next couple chunks, we have another big summarizing table. So just like we had a big summarizing table here, there's another one coming up too, so you won't have to go back to all the slides. That will reference those values for you. Okay? Good. So we're going to move on to our next angle measure, which deals with 30 degrees and 60 degrees. We're going to pretend like these aren't here right here. I meant to cover those up and I forgot. Okay, so we need to figure out pi over 3 and pi over 6. Pi over 6 is the same thing as your 30 degrees, so this would be a pi over 6 angle, and pi over 3 is the same thing as 60 degrees. Remember, your pi values are your radian values, your other values are your degrees. So just two different ways to talk about the angle. So notice here I've set up a right triangle, just like I did back here with my 45, 45, 90. Set up a right triangle and used it to solve for my x and my y. Same thing here. I've set up a right triangle, and my hypotenuse again is 1 because that's the radius of the circle. Envision there's a big circle that goes around like this, and here's my origin with a radius of 1. Okay, that's what this triangle is representing. Now, in order to figure out my sides, A and B, what they did is they doubled the triangle. So they just doubled this triangle, and now my left and my right side are both 1, and this is an equilateral triangle now, which means that this length here is also 1. So then A is half of 1, or 1/2. So now I know that my side length A, or this length down here, is a length of 1/2. So C is 1, A is 1/2. I need to find B. Again, I'm going to use Pythagorean theorem. 1 squared is equal to 1/2 squared plus B squared. Looking here at this triangle, here's my B. I need to solve the Pythagorean theorem for B. 1 squared is 1. 1/2 squared is 1/4. So 1 is equal to 1/4 plus B squared. Subtract 1/4 from both sides. 3/4 is equal to B squared. And square root both sides. So I get the square root of 3 over the square root of 4 is equal to B. And square root of 3 can't be reduced, but the square root of 4 is 2. So B is equal to the square root of 3 over 2. So this point, which would be the point on my unit circle that I would care about, is actually the point. My x value is 1/2. My y value, square root of 3 over 2. Again, you won't have to recreate this. Just want you to have a little bit of a background where these numbers come from. So using that, I can throw that into my circle. Here's exactly what I was just looking at. But notice, here's what I was looking at. So here's my 60-degree angle. I've come over 1/2 up square root of 3 over 2. So I'm at the point 1/2 square root of 3 over 2. So now let's find our 6 trig functions at pi over 6. Sine of pi over 6 is my y value, square root of 3 over 2. Cosine at pi over 6 is my x value, which is 1/2. Tangent at pi over 6 is y divided by x. So I'm going to take the square root of 3 over 2 times the reciprocal, 2 over 1. 2's cancel, and I get square root of 3. And let's go ahead and find our reciprocal values. Cosecant at pi over 6 is 2 over the square root of 3. Can't have square root in the denominator, so rationalize that denominator. Multiply top and bottom by square root of 3. So I get 2 root 3 over 3 is my cosecant value. Secant at pi over 6, reciprocal of 1/2, which is just 2. And cotangent at pi over 6, 1 over the square root of 3. And again, rationalize that denominator, multiplying both top and bottom by the square root of 3. And I get the square root of 3 over 3. Questions there? Okay? So, I know I'm overwhelming you. We're over halfway through. We're just going to keep repeating, mostly we're just going to keep repeating this process. Now, look at my next slide. I'm talking about pi over 6 here. I'm taking this triangle, and all I'm doing is I'm rotating it. I'm flipping it 90 degrees the other way. So my 30-degree angle is here. So it's very similar, but this time notice my x and my y are switched around. I've gone to the right square root of 3 over 2 and up 1/2. Again, you don't have to memorize that. I just want you to have some background as to where it comes from. Now, I want you to try finding your 6 trig functions on this one. Check your work with mine as you go. Give me a thumbs up when you've got it good to go, or ask any questions that you have. I'll stay quiet as I fill in my chart. Why is it 1/2? Because all we've done is we've flipped this triangle. So the short side is 1/2, the long side is square root of 3/2. So looking at here, now my short side corresponds to my y, and my long side corresponds to my square root of 3/2. So just flipping where the x and the y are. This would still be a 60-degree angle right here. So all we've done is rotated my triangle. Okay? So go ahead and try finding those 6 trig functions. Oh, I had a typo on the last one, didn't I? On the last picture, all of these should be pi over 3, not pi over 6. I'm sorry. I was getting ahead of myself. So this was the previous slide we just did together. All of those should be a 3, not a 6. You might want to fix that if you wrote it wrong too. Oops, and I wrote it wrong again. Yes, okay. So if that half didn't answer, yes, okay, yeah. It's half because it's half of this triangle. Because we doubled it to make it equilateral. Good. Any other questions? Your question about switching 2 to 1, is that right from this step to this step? What I just did was I had a 2 on top and a 2 on bottom, so they canceled. So 2 over 2 is just 1. So the 2 became a 1. Good question. Give me a thumbs up when you're feeling good about this or if you have any questions. Okay, I've got 2 that are good to go. Three that are good to go. Oh, 4 that are good to go. Okay, all right. So I feel like I'm slowly but surely getting less questions from you, which I'm taking as a good sign that maybe it's kind of clicking, coming together here a little bit better. Here's our summarizing slide that I said we'd have. So all of that work we just did can be summarized right here. We found pi over 4 was when we had the 45-degree angle, pi over 6, and pi over 3, and they're all listed here. So just kind of a reference for you, although honestly I think you'll probably just use the unit circle the most. Okay, we're going to take a break from the circle for a little bit, talk about, I think this process is actually a little bit easier. So it says the rain gutter is to be constructed of aluminum sheets 12 inches wide. After marking off a length of 4 inches from each side, this length is bent up at an angle of theta. So we've taken this steel piece, bent up, or aluminum piece, bent it up at an angle of theta. So these two are bent at the same angle. The area of the opening may be expressed as angle of theta is equal to 16 times sine of theta times cosine of theta plus 1. Kind of wordy, right? Find the area of the opening if we have a 30-degree angle, a 45-degree angle, and a 60-degree angle. So let's look at this here. This first slide, we're going to find our angle, or our area if we have a 30-degree angle. So we're finding area of a 30-degree angle. Means I'm going to replace all of my thetas with 30 degrees. So 16 times sine of 30 degrees times cosine of 30 degrees plus 1. Now we know what sine of 30 degrees and what cosine of 30 degrees is. So 16 sine of 30, well, let's come over here back to my chart. 30 degrees, sine at 30 is 1/2. So I'm going to replace sine of 30 with 1/2. Times cosine of 30, again, go back up to your chart. At 30 degrees, cosine is the square root of 3 over 2. So I'm going to replace cosine of 30 with the square root of 3 over 2, and then plus 1. Now this is simply something we can put into our calculator. 16 times 1/2 times the square root of 3 over 2 plus 1. And when we do, we get it about 14.93 square inches. So if my aluminum was bent at a 30-degree angle, I'd have almost 15 square inches of area underneath. Let's try it at 45 degrees. Let's see how much area I would have if I bent my aluminum at an angle of 45 degrees. So again, just replace all of your thetas with 45 degrees. So 16 times sine of 45 times cosine of 45 plus 1. And substitute in what we know to be true. Sine of 45, over here on your chart, 45 degrees. Sine is square root of 2 over 2. So I'm going to replace sine of 45 with root 2 over 2. Times cosine of 45, come back to your chart, cosine is also square root of 2 over 2. So I get square root of 2 over 2 plus 1. Again, plug this into your calculator and you get approximately 19.31 square inches. So if you bend them up further to a 45-degree angle, you're going to get 19.3 square inches of area underneath those aluminum bends. Let's do our last one here and find the area if I bend my aluminum at a 60-degree angle. So again, replace all of your thetas with 60. Oops, I'm going to get rid of this. I don't want this. And I want you to finish solving this one on your own and just check yours with mine on the screen when you're done. Questions, comments, concerns? Or are we still working? Yes, Rachel, but give me a minute because I want others to look at this first. Okay, so it looks like we're all good. Here's, I had a request to see the slide again. Okay, so if you're not getting the right thing when you punch it in the calculator, make sure you're using the parentheses around this whole part right here. And this is a different one, but it's the same kind of thing. Using parentheses around this part. And if you're using a graphing calculator, make sure that you're not putting square root of 3 over 2 all under your radical. You're just putting square root of 3 and then plus 2. And if you're having calculator issues, holler at me at the end of the lesson and I'll help you, okay? Rach, you good? Okay, great. So we're going to kind of finish up here. And I know we've been in for almost an hour today, but your patience is great. I really appreciate it. We're finishing up with the very last kind of putting it all together summation of this lesson. So we looked at, the first thing we looked at was finding, well, not the first thing, but the first one besides our origin and our axes was finding 45 degrees. Now, what we've done here is I've rotated my 45 degrees into all of these quadrants. So notice how I've just simply reflected this point of my pi over 4 into this quadrant. And notice here I'm adding 2 pi over 4 to get to each of my new locations. And since I'm just reflecting, my point is staying the same. My x and my y's are staying the same, but my signs are changing. So since I've reflected across the y-axis, my x-coordinate here for 3 pi over 4 is now negative. My y-coordinate is still positive. Reflected over the x-axis one more time, I have both x and y negative, and then one last time and I have x positive and y negative. And again, I'm adding 2 pi over 4, which is really just pi over 2, but I'm adding 2 pi over 4 each time to get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. We're starting to build our unit circle here. So let's use this part, the 45-degree angles, to find some values here. And there's 2 slides, I think, so if you need extra room to write, there are 2 slides here. So the first one says cosine of 135 degrees. Well, I don't have degrees marked here, but if this is 45 degrees, this is 90, this 3 pi over 4 would be the same thing as cosine of 135. So if I'm finding cosine of 135, it's the same thing as finding cosine of 3 pi over 4. And cosine, remember, is our x value, so that would be the square root of 2 over 2. Part B, so really notice it's just the same process we were practicing, but we're just kind of adding some more points to deal with. B is tangent of 3 pi over 4. 3 pi over 4 is this point right here, and tangent is is y over x. So tangent of 3 pi over 4 is y, which is the square root of 2 over 2, times the reciprocal of x. I'm going to just skip a step here. Negative 2 over the square root of 2. Multiply across 2 root 2 over 2 root 2, negative 1. C, sine of 225 degrees. Well, again, remember, if this is 0, 90, 180, 225 here, sine of 225 degrees would be the same thing as 5 pi over 4. If you're not sure about that, go ahead and use the conversion we learned last time to convert degrees from radians and back and forth, and you can always double check your work that way. So 5 pi over 4, I'm looking at this point down here. Sine is my y value, so negative square root of 2 over 2. Part D, cosine of negative 5 pi over 4. So just like with degrees, negative means I need to go clockwise from the positive x-axis. So if I'm starting here going clockwise, this point now becomes pi over 4. This point becomes becomes 3 pi over 4, and this point would be negative 5 pi over 4 because I'm going clockwise. So cosine here is negative square root of 2 over 2. And my last one, E, sine of 9 pi over 4. Again, starting here, when I go all the way down to here, I'm at 7 pi over 4. So if I want to get to 9 pi over 4, I've got to add another 2 pi over 4. So 9 pi over 4 actually corresponds to this point here. 9 pi over 4 is the same value as pi over 4. And to find sine of that, I need my y-coordinate, square root of 2 over 2. Questions on that much? So same kind of process, we're just kind of adding a few little more things we can do with it. So we're nearing the end. Okay, Hannah, no problem. Thanks for sticking around. It wouldn't be a bad idea to watch the last couple of minutes of the recording. I'll post it as soon as it's done. Okay? Okay. Oh, this is the same slide. So now, I've done the same thing with those other two, the 30 degrees and the 60 degrees we looked at. Excuse me. I'm reflecting them across all of my axes. So notice now, this isn't as nice of a reflection. My x and my y aren't the same like they were with my 45 degree. So when I reflect pi over 6 over the y-axis, notice that I'm adding 4 pi over 6. But when I reflect it down to the x-axis, over the x-axis, I'm only adding 2 pi over 6. And then another 4 pi, and then another 2 pi. Again, not that important, you have that memorized, but just kind of know where it comes from. And then I've done the same thing here. I've taken my pi over 3, reflecting it over the x, or excuse me, over the y, then over the x, back over the y, and back up. So, oh, you know what? I want these on this slide so we can reference them. Okay, so let's reference these. And you can't read that, can you? And let's find our values. A, cosine of 50 degrees, we have to find where 50 degrees would be. Well, 180 is straight up and down. If I add an extra 30, that's like adding an extra pi over 6. That's this point right here. So cosine at this point is negative 1/2. Sine of negative 30 degrees, remember we said sine, or negative means go clockwise. So starting here, if I go down 30 degrees, I'm at this point here, and my sine is negative 1/2. C, tangent of 4 pi over 3, we'll just simply locate 4 pi over 3. That's this point right here. Tangent is y over x, so tangent of 4 pi over 3. Y is negative root 3 over 2 times, find your reciprocal, negative 2 over 1. 2's cancel, negative times negative is positive, so I get square root of 3 over 1, which is just square root of 3. And lastly, D, sine of 7 pi over 6. Locate 7 pi over 6 on your circle. That's this point right here, and my sine is negative 1/2. Questions on any of that? Okay. So, in the beginning, Austin said, can't we just use our calculators for this? It depends. Now notice, well, in this case, square root of 3 is an irrational number. So when it says find the exact values, you have to leave it as square root of whatever you have. And we have a lot of irrational values, a lot of square roots when we're working with trig functions. You can see that in our table. Oh, that's not the table I wanted. This table. A lot of these are irrational numbers. So if you just plug it into your calculator, it's going to have to give you a rounded answer, which is not exact, in which case it won't work to just plug in your calculator. So really you don't want to use your calculator unless it specifically says use your calculator to approximate. So to do that, how many of you have a handheld graphing calculator? Landon, I know you do, and Austin, I know you do. Please get those out. Emma and Rachel, what kind of calculators are you using? So Rachel, just a scientific one? Okay, so we're going to be switching here between degrees and radians. So without knowing exactly what calculator you have, I can't tell you exactly how to do that. I'll tell you on the graphing one, so Landon and Austin, follow my graphing instructions. And I'll show you on an online one, and then if you need more help, Emma, just let me know, and I'll have to see your calculator. Okay, the one on your calculator? Okay, cool, I'll do it on this one too. This one is actually very easy to do. So Landon and Austin, you want to first make sure that you're in degrees mode because we want to find cosine of 48 degrees. Okay? So Landon and Austin, do you have your calculators out? Okay, so hit mode. Mode is in the upper left-hand corner next to the second button. And scroll down, 2 down, and then you should go over right 1, and degree should be highlighted, not radian. If degree is not highlighted, put your blinking cursor on it and hit enter. And then hit second mode, and it will quit you out of there. Questions on any of that? So now, to find cosine of 48 degrees, Landon and Austin, simply hit cosine and then type in 48, enter. And you should get 0.6691, yada, yada, yada. Tell me if you don't. Okay, Rachel and Emma, using I'm just going to use this one that's already on our computers. I'm in scientific mode by hitting View Scientific. Now, for you to switch back and forth between degrees and radians, it's very simple. Just make sure your degrees is selected. And yours will be different because you'll start by typing in your number. So we're going to take 48, and then we're going to hit cosine. And that's your 48 degrees, cosine of your 48 degrees. So round to 2 decimal places, 0.67. So now, cosecant, we don't have a button for that on our graphing calculator or on our scientific calculator. But remember we said cosecant is simply the reciprocal of sine. So cosecant of 21 degrees is equal to 1 divided by sine of 21 degrees. So, still stay in your degrees, Landon and Austin, 1 divided by sine of 21 degrees. Okay, and Emma and Rachel, in your graphing or in your scientific calculator, you're going to do 1 divided by, open parenthesis, 21 sine, end parenthesis, and then hit enter. So one more time. 1 divided by, open parenthesis, sine, oh, no, not sine, sorry. 21 sine, what did I do? Oh, I don't know what it's saying. Okay, try it again. 1 divided by, open parenthesis, 21 sine, end parenthesis, enter. 2.79. And for part C here, anytime it doesn't say degrees, it's implied radians. So we need to go back and switch our calculator to radians. So Austin and Landon, go back to mode, which is just to the right of your second button. Scroll down to radians. So your cursor should be flashing over radians. Hit enter on top of radians, and then second mode, quit out of there. Then you'll do the same thing. Tangent, pi. Pi is second and the caret button, which is right above division, over 2. Oh, over 12. Pi over 2 does, tangent pi over 2 doesn't exist. And let me know what you get. And for the girls, over here, it's even easier because you just have to click radians. And now same thing, you have to use your parentheses. So parenthesis, pi divided by 12, end parenthesis, and then tangent. Enter. So 0.27. Questions on using your calculator, solve. Pi divided by 12. Yes, so notice in this calculator you have a pi button right here. So again, you have to do it in parentheses though. Parenthesis, pi divided by 12, end parenthesis, and then hit tangent. Enter. Questions on using a calculator to solve. Okay, so we got one last example and then we will finish up with our unit circle. So in all the previous examples, we've been able to find sine by simply sine of theta by saying it's equal to y. Cosine is equal to x. Well, really, sine and cosine are not equal to y and x. They're equal to y. Sine of theta is equal to y divided by the radius. Cosine of theta is equal to x divided by the radius. But since in all of an example so far, we're looking at the unit circle, which has a radius of 1, we were able to ignore the r, the radius, in all of these examples. So let's see what happens when I look at an example when I don't have a radius of 1. So it says find the exact value of each of the 6 trigonometric functions of a positive angle theta if 4, -3 is a point on its terminal side. So for -3, I want to find that point. I'm just going to plot it so I have a visual. For -3 is this point right here. So in order to find all the 6 trig functions, I can't just use the x and the y. I have to know the radius, and in this case, my radius wouldn't be 1. I'm not part of my unit circle. So what I'm going to do is I'm going to set this up into a right triangle. Okay? And this length here is a length of 4. And this length here is a length of 3. That's where I get this point, 4, -3. So if I have a right triangle and the legs are 4, 3, does anybody remember what my hypotenuse has to be? If I did Pythagorean theorem, what would I get? It's a Pythagorean triple. Okay, we'll do it then. So we'll call this C. So 4 squared plus 3 squared equals C squared. 16 plus 9 equals C squared. 25 is equal to C squared. C is equal to 5. So actually 3, 4, 5 is a Pythagorean triple. It gives us a nice triangle. So my radius is 5. So let's go back here. Well, actually, so I want to find sine of my angle theta. And remember, sine is equal to y over your radius. So sine is equal to y over r. Y in this case is -3. R is 5. Cosine of theta is x over r, which would be 4 over 5. Tangent of theta, that's still y over x, so I simply have 4 over -3. Cosecant of theta is my reciprocal still, so either r over y or -5 over 3. Secant of theta is r over x, 5 over 4. And cotangent of theta is -3 over 4, or x over y. So find your hypotenuse length and then use these values when r is not 1. So I'll make that a note. When r does not equal 1, use these. Okay, you guys have been awesome today. I know this took a lot longer than I thought, but I really wanted to go through it with you. Now, taking everything we've learned and putting it together, this is your unit circle. Okay? All those points we talked about are listed on here. So if I ask you to find cosine of 11 pi over 6, locate 11 pi over 6. It's the point square root of 3 over 2 and -1/2. Cosine at 11 pi over 6 would be square root of 3 over 2. Okay? So absolutely doable. Use this. I just want you to know where we got all these numbers from. My head feels like it's going to explode just looking at it. I know where you're coming from. Just kind of bear with me. Try your homework problems. Use this unit circle. Now, this link I provided down here, it's in the bottom of your notes too, just another approach to finding the unit circle. So if you're kind of overwhelmed, you're not sure, check that link out. Google the unit circle. There's lots of different ways that you can go over it. Will I be posting this PowerPoint? Yes, I'll post the PowerPoint as well as the recording. I have a request to go back to slide 40. Here's slide 40. So all of that work we did today was really just creating what I showed you in that last slide. Just creating that unit circle. Unit circle is key to so much trigonometry and calculus that the better background knowledge you have of it, the better off you'll be. Now again, I'm not making you memorize it because I can't monitor you at home, but I guarantee you if you take a class at the college level, a math class, anywhere beyond college algebra, you will have to have the unit circle memorized. So just kind of be aware that can happen someday. Okay, you've all been great. I so appreciate you coming. Hopefully you took away something important, learned a little bit, and I will see you all on next Monday. Please let me know if you have any questions. Okay? Otherwise, adios.